All right, today we are going undercover. Think of us as disease detectives. Our mission, to crack the code of outbreaks and figure out why some just fizzle out, while others seem to explode. You've probably thought about this, right? One incident is contained almost immediately, but then another one becomes this long, drawn-out crisis. And it might look random from the outside, but it's really not. There's a logic to it, a story that's being told in the data. And the key to solving this whole mystery, to really understanding the story of an outbreak, it honestly boils down to one single fundamental concept. If you get this one thing, everything else just kind of falls into place. And here it is, the big clue: exposure. Now, it sounds simple, I know, but this is so important. It's not just about if you're exposed, it's about how you're exposed and when. The nature of that contact, that's everything. Exactly. The pattern of the exposure, that's the fingerprint left at the scene. And for a trained investigator, that fingerprint tells the whole story: where the outbreak came from, how it's spreading, and most importantly, how to stop it. So let's bring in our first suspect. This one's the most straightforward pattern, the one that, thankfully, often gets solved the quickest. We're talking about the single event exposure. Think of this as a one-and-done kind of situation. You've got a group of people, one source of illness, all happening in one short window of time. The exposure happens, and then poof, the source is gone. A classic example here is something like food poisoning at a picnic. Everybody eats that same sketchy potato salad around the same time. So what happens next? Well, it's pretty predictable. You get a sudden, sharp spike in illnesses, but only among the people who were actually there. And this is what's so cool. It leaves behind a very specific signature. When you plot the number of sick people over time on a graph, what we call an epidemic curve, you see this really distinct shape. It shoots up fast as people get sick, and then it drops off just as quickly. It looks like a single, sharp mountain peak. For investigators, seeing that shape is actually a huge relief. It means the culprit has already left the scene, and the job becomes about treating the people who got sick, not trying to contain an ongoing threat. Okay, let's move on to our next suspect, and this one is a little trickier, a bit more deceptive. This is the on-again, off-again pattern, sometimes called multiple or intermittent exposure. So, with this one, the source isn't a one-and-done deal. It shows up, and then it disappears, and then it comes back. People get exposed, things might seem to get better, and then, bam, they get exposed all over again. A good way to picture this is a community well that gets contaminated every so often, maybe after a heavy rain. So people use it, they get sick, then the contamination might clear up and the number of cases drops, but then it rains again, the well gets recontaminated, and a whole new wave of illness pops up. It's irregular. And of course, you can see the difference in its fingerprint. Instead of that one sharp peak, the epidemic curve looks more like a mountain range, a series of peaks and valleys. Each one of those peaks represents a new exposure event, and that's a telltale sign to investigators that the culprit is still out there, striking at irregular intervals. It tells them they're hunting for a source that can be turned on and off. And that brings us to our last and, frankly, often the most dangerous pattern: the constant or continuous source exposure. This is that persistent threat that just will not go away on its own. So here, the exposure isn't quick, and it's not on and off, it's ongoing. The source of the problem is always present, and people are just continuously coming into contact with it, day after day. The scenario for this one is usually much bigger in scale. Think about something like a city's entire public water supply being contaminated before anyone realizes it. Every single day, more people are being exposed, which leads to this steady, relentless stream of new cases. It's a huge problem. And its signature is unmistakable. The epidemic curve here doesn't have peaks at all. Instead, the number of cases rises, and then it just levels off, forming this long, high plateau. That plateau stays steady, day in and day out, until the source is finally found and shut down. Only then do the case numbers finally start to fall. So there you have it. We've seen our three main suspects and their very distinct fingerprints. Now let's put them all side by side and crack this case once and for all. This really puts it all together, doesn't it? The single event, like bad picnic food, gives you that one sharp peak. The on-again, off-again source, like the tricky well, creates a whole mountain range. And that constant source, the city water supply, that gives you the long, dangerous plateau. 3 patterns, 3 stories, and 3 completely different looking curves. And this is why this is all so incredibly important. The shape of that curve is basically an action plan for public health officials. A sharp peak tells them to look for a single event that's already over. But a plateau? That's like a blaring alarm bell, telling them to find a dangerous source that is still active right now. Reading the pattern is the very first step to shutting it down. It really makes you think, doesn't it? The simple shape of a graph can literally save lives by pointing disease detectives in the right direction. And it just begs the question, what other invisible patterns in our world and in our own behavior are quietly shaping our health every single day?